Hello everyone, in this video we will be exploring web scraping with Python, using the Selenium library. Selenium allows us to automate browser interactions and extract data from dynamic websites. It combines the power of Python with the ability to control web browsers programmatically. Python provides the tools for data manipulation, and Selenium handles the complexities of modern web pages. Let's get started by understanding what Selenium is and how it works. Selenium is a powerful browser automation framework, which allows us to control web browsers programmatically. It is especially useful for interacting with dynamic JavaScript content, which is common in modern websites. Selenium supports multiple browsers, including Chrome, Firefox, and Edge, giving you flexibility in your scraping projects. Originally designed for web testing, Selenium has become a favorite tool for web scraping because of its ability to handle complex, interactive websites. On the right side, you can see a basic Selenium setup in Python. First, we import the necessary modules from the Selenium library, including the WebDriver, Service, and Chrome Driver Manager. Next, we initialize the Chrome browser using Chrome Driver Manager to automatically handle the Chrome driver setup. Finally, we navigate to a website using the get method. One of the key tasks in web scraping is locating the elements on a web page that contain the data you need. Selenium provides various methods to find elements, each suited for different scenarios. Here we'll explore some of the most commonly used methods. On the left, we can see the different ways to find elements using the ID, class, and tag name. We first import the by class, which is used to specify the type of locator. For example, to find an element by its ID, we use the findElement method with by.id and the ID of the element. Similarly, we can find elements by class name or tag name using by.className and by.tagname respectively. On the right, we have examples of finding elements by cascading stylesheet selector and XPath. Cascading stylesheet selectors are patterns used to select elements based on their cascading stylesheets classes, IDs, and attributes. XPath is a query language for navigating through the hypertext markup language structure of an extensible hypertext markup language document. Additionally, we can also find elements by their link text using by.linkText. Once you've located the elements you need, the next step is to interact with them to extract data or perform actions. Selenium provides various methods to interact with web elements. Selenium allows us to type text into input fields, click buttons and links, extract text and attributes, wait for elements to load, and scroll to view elements. On the right side, you'll see code snippets demonstrating common element interactions. To type text into a search box, we first locate the element using by.name. Then we use the send keys method to enter the text and simulate pressing the return key. To click a button, we locate it by its ID and use the click method. To get the text from an element, we locate it by its class name and access its text attribute. Now let's put everything together with a complete web scraping example. This example demonstrates how to scrape product information from a website. First, we set up the driver and navigate to the target website. Then we wait for the page to load using the time.sleep function. Next, we find all the product cards using their class name. After that, we iterate through each product card and extract the name and price of the product. Finally, we store the extracted information in a list of dictionaries. Remember to handle exceptions, add proper weights, and respect website terms of service when scraping. To ensure your web scraping projects are robust and ethical, here are some best practices and tips to follow. Always use explicit waits instead of time.sleep to wait for elements to load. This makes your script more efficient and less prone to errors. Add retry mechanisms to handle intermittent network issues or website errors. Respect robots.txt and rate limits to avoid overloading the website server and potentially getting blocked. Use headless mode for production to run the browser in the background without a graphical interface. Store data in structured formats such as comma-separated value or JavaScript object notation for easy analysis and manipulation. On the right side, you'll see examples of using explicit waits and headless browser mode. Explicit waits allow you to wait for a specific condition to be met before proceeding. Headless mode allows you to run the browser without opening a visible window. Web scraping isn't always smooth sailing. You'll often encounter challenges that require creative solutions. Let's look at some common challenges and how to overcome them. One of the biggest challenges is dealing with dynamic content loading with JavaScript. To solve this, you should use explicit waits and proper timing strategies to ensure elements are fully loaded before attempting to interact with them. Another common challenge is CAPTCHAs and anti-bot measures. You can implement human-like behavior patterns to avoid triggering these measures. Handling login sessions and cookies can also be tricky. You can save and reuse cookies for authenticated sessions to maintain your logged-in status. Websites with changing layouts can break your script. It is important to use robust selectors and fallback mechanisms to adapt to these changes. Performance issues can arise with large-scale scraping. Implementing parallel processing and using proxies can significantly improve performance. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.